Hello, I'm Dennis O'Donnell, Vice President of Precision PCB Services, and I want to welcome you to my live broadcast on BGA component rework. We at Precision PCB Services, we provide a sales, service, consulting, and employee training for most all makes and models of BGA Rework Stations. We are a distributor of a brand new Shuttle Star and Zumao BGA Rework Stations, and then we sell some used SRT, Airvac, and other model BGA Rework Stations as we have them available. Right now I'm going to be demoing this SRT 1000. I believe this is a 1998 model. Well, this is a June 1996 model. It's a really nice unit. It's had, even though it's an older unit, it's had very little usage. Right now we also have available an Airvac DSR 22. But today I want to demonstrate to you the operation of the SRT 1000. And this is similar to the 1100s, 1100HRs. So it's, even though it's got the older software, it's pretty similar to what the 1100HRs are. And then your newer software has a lot more features on it, but the way it operates is also similar. So we're going to show you some software operation, profile setup, and we're also going to show you machine operation, excuse me there. So without further ado, let's we'll get started here. So when we first come to our machine, we have at the top of the screen here our board, our component site, and our sequence. If you look for our video on this part one of this video, I have a close-up view of the screen for the software operation. So I would suggest if you want to get a real close-up of how we're operating the screen, watch part one. So I'm presuming a lot of people have watched part one, so we don't have to have a close-up of the screen right now. But what I would want to do when I first walk up to the machine, I would want to get my board, and I would want to know which board it is. And normally they'll program the boards by the assembly number, or maybe some companies will program the board by the project name. Right now I just have up in here, I can click on change, and my list of boards will come up. And right now I'm just using the SRT demo board. And then we have a component site. I'm going to select my component, and it's the same thing. Your list of parts will come up, and I can select my component site. Right now, I'm just using the generic, because of the machine, it's called BGA 225. And then we have our sequences. So we'll click on sequence and change. I'll look in here, and we have different commands. You have pick and place. So if I just wanted to pick the component up and place it on the, align it and place it on the machine, I would pick and place. I have place, release, reflow. So if I want to pick the component up, line it up, place it, release it from the pickup tube and then reflow it, then that will be my place, release, reflow. If I just want to reflow the site, say if somebody has a component and they is not going down well, they just want to put some flux in it and reflow it, I would select reflow site, and then if I want to remove the component, I would select remove on it. So for right now, let's go ahead and we'll start with a pick and place. Let's just pick and place the component. So I've selected that, I'm going to click OK. Now, if this was a board that wasn't already set up for a profile, we might want to set up a profile for this board. And so what I'm going to do, I'm going to go up here. On the top of the screen, we have a set of commands. I'm going to click on the word process. I'm going to click on the word time and temps. And then my profile setup will come. And I have a preheat setting on the top, and I have a reflow settings on the bottom. And I have my heater ramp. That's my, they call it your ramp or your dwell, how fast I want it to heat up. And we have our top heater set point and our bottom heater set point, and then our time in seconds, and that's how long we're going to hold it after it reaches that set point. And then for the reflow settings, we have the same thing. We have our ramp, or how fast we're going to speed up the heat, our top heater set point, and our bottom heater set point. So what I'm doing when I'm profiling a board, it's going to depend on how heavy the board is, whether it's lead or lead-free solder. This particular board now, we have lead solder. It's not too heavy. Whether it's a heavy board or not, what I do is I put a thermocouple on the bottom of the board underneath the component. And so what I'm doing is I'm shooting for lead. I want to get about a 190 to 220C bottom side board temp to get a good reflow. And for lead free, I'm looking for about a 230 to 250 bottom side board temp. So what we're going to do, we're going to put the board clamps on the machine. We want to be familiar with our machine, what the heater output are. So I always recommend that you run tests on your bottom heater and top heater to see what their maximum output is. If I'm setting my top heater at 240, is 240 actually coming out the nozzle, or is it 10 or 20 degrees less, or 10 or 20 degrees more? And so this machine is pretty accurate. It's what's coming out the nozzle here is what the setting is at. But if it's not, you want to either get your machine calibrated, or you want to at least make a note of the differential so what you're setting profiles. Again, not all SRTs are the same. The SRTs have bottom heaters. They come in different wattages. And so some bottom heaters will get hotter than the others. Also, if you look at the different machines, there's a different amount, all the bottom heaters are not set exactly the same amount of space from the board to the heater. So some of them have a closer, some of them have a larger gap. So you may have more space, which will allow the heat differential to be more. So right now, what I'm going to do is on the SRTs, on most of my BGA Rework Stations, I like to use a ramp of 1 degree per second. So that means my heat's going to heat up 1 degree per second. And what we're trying to do is we're trying to create, the manufacturing process of a reflow oven. The reflow oven, we don't heat the stuff up really fast. You usually get a reflow oven is about 2 degrees per second or 3 degrees per second. With the reflow oven, you can go faster ramp because you have an atmosphere that's completely saturated in heat, and you have a lot of different zones, so you're getting more rapid heat. With this, we have a bottom heater that's heating up slowly. Every time we restart the machine, the heater has to heat up again. It's not like a reflow oven, which is already warmed up and ready to go. So we're only using the bottom preheat, and then the top is only selectively heating. So I go with a slower ramp on the BGA Rework Station because it takes more time for the bottom heater to soak up. It takes more time for the board to absorb the heat. I've been doing this for about 20 years now, and a 1 degree per second has been a real ideal ramp rate for me, and it's provided high yield, high success. So I pretty much stick with that for all boards. Also, so I got my ramp set on the top and the bottom, or the preheat and the reflow at 1 to 1. Now I'm looking at my top heater setting for preheat. So I want to try and get my board up to about 180 degrees. They recommend 150. I go a little hotter, 180 degree bottom side board temp preheat on the preheat end. So I'm going to set my top heater right now for 240. I'm going to set my bottom heater for 240. Once it reaches that, I'm going to allow it to hold that temperature for 60 seconds. This will allow all my heaters to make sure they are completely up to that temperature, and allow the board to make sure it's completely up to that temperature. So we set our reflow settings. I have it 270, 270. And I'm going to hold that for 60 also. So 270 top, 270 bottom. And so what we're hoping is at the end of this profile, we're going to have about a 190 to 220 degrees C bottom side board temp, and the solder should be reflowed at that point. So let's go ahead and we'll give it a try. It's going to take about 5 to 7 minutes to run the whole profile, but it's worth watching. I'll show you what's going on while we're running it. All I'm going to do is I'm going to click here. I've got I'm going to do a pick and place. I have my chip on the upper net. They have an upper net and lower net. So with the pick and place, it's going to pick up from the upper net. If I wanted to pick up from the lower net, I would use the command LN pick and place, which is lower net pick and place. Let's click on run. I'm going to pick up the component. It tells you what I'm doing. I'm picking up the component. Waiting for the pickup. Okay, so now tell me, center the site in the video and press go. So what we're going to do, we're going to take this, place this component. We have our site centered in the video. Now we're going to press go. Okay, so our site's centered. And now what we're going to do is we want to align our solder balls. So I'm just going to get a basic alignment going here. This machine has a dial adjust. The nicer newer machines have a micrometer adjust, which allows me to be more accurate, especially for fine pitch devices. And then I'm going to zoom in a little bit here. So I can zoom into the center balls. Just move this over here. And I can go to my part lighting. So I can go ahead and I can adjust the lighting for my board or my component site. And I can focus that a little bit. And so now my BGA pads are focused on the screen. What I'm going to do is I'm going to turn the BGA pads off. I want to focus my solder balls. These are pretty much in focus, but if I want to focus the chip, if it's out of focus, I don't want to focus on the microscope here. I use this microscope is to focus the BGA pads on the PCB. What I'll do here to focus the chip is I'm going to take my arrow. At the top of the screen here, there's a little black line. I'm going to click right above that black line. I'm going to double click. And when I double click above that black line, it brings out a command screen here. What this allows me to do, I double click to bring up the command screen. And then what I do is I go on the screen, there's a pickup screen here, the second screen. I'm going to double click on the inside gray area. And that's going to bring these up down arrows up. What this will allow me to do, I can move the component up and down in the prism. And this will allow me to do a better focus on the solder ball. See, if I go down, they go out of focus. If I go up, they focus better. If I go up too much, they go out of focus again. And so right there, that's about a good focus. What I want to do is I want to zoom back out. And I want to move my, let's get our PCB light on now and our solder ball light on. Now we're seeing our component and our circuit board at the same time. So what I want to do is I want to make sure the pads are lined up all the way across. They have an X, Y, and a theta. My theta or my Z-axis is on the left knob here. There's the knob right here. And I'm just going to turn this, and this will adjust my component. And so now I can see my solder balls are lined up straight all the way across, all the way down. So what I'm doing here is I'm just adjusting my board. I got the pad next to the ball, and I'm making sure that they line up from the top to the bottom. If I I line up at the top and I go to the bottom, it's a little bit off. It will, again, jog this up and down. What this will do when you jog it up, narrow down, it focuses, but it also stretches the balls because the camera has a curve, and it sort of stretches them. So we're just going to go. So I just click it down about 2 clicks, and we'll go back up 1. Oops, there. There we go. I just 1 click and it stretched the balls enough. You can't. I don't know if you can see good enough on this screen, but if you go to my part 1 again, it'll have a close-up of us doing this. But now I have the solder balls exactly matching the pads Now I'm just going to move this over, and then I can zoom in all the way, and we can see there's our pads, there's our ball. Move it over, and they're 100% on. They're 100% on the pads now. Sounds good. If this is a large shift that went beyond the vision of our camera, most of the machines will have a split vision mirror here. What you do is you can screw this little dial in, and it'll bring in the corners of the pads so you can line up the corners on the chip. I'll show you that down. Just screw that in. It'll allow me to line up the corner pads if the chip is too large. But with this chip, it's just fine. It's the right size. So again, we have our command screen on the bottom telling us what to do. It says align part. Press go. So I'm going to press go. Let's go to place the chip. So normally if I was going to install the chip, I'd use the command place, release, reflow. But just for demonstration purposes now, I'm just showing you, and we're just using to place it. So now the chip is placed, we're going to go ahead and reflow it. So I'm going to press stop. I'm going to go back to our sequence here. And I'm going to select reflow site. And now we're going to select run. And again, let's go through our commands. This tells us to center the board site in the video screen. Make sure that my board is centered, or my component is centered in the nozzle. We also, if you need SRT nozzles, we could custom make SRT nozzles for the SRT machine. So give me a call if you need any nozzles. But now our component is centered in the machine. It's telling us once the board is centered in the screen, press go to continue. And so basically it tells you what it's doing here in the screen here. Right now it says it's waiting for our bottom heater to reach a 235 C preheat. So the bottom heater is rather cold, and we have to wait for that to come up to heat. So while the bottom heater is coming up to heat, it's also preheating the board. And so our top nozzle won't come down until the bottom heater has reached its initial preheat stage. So we have our top heater thermocouple here. Reading out what the top heater is, which is it's not going right now. It's at 25. It's not turned on yet. And then it's reading what our bottom heater is at. Right now, our bottom heater is about 115, and we're going to wait for it to heat up to 240. Well, the next thing I'll do while I'm running this profile, I'm going to bring up our graph so I can see what the different thermocouples are reading. I bring up my graph here, and with this unit, you can have up to 4 external thermocouples. I think the newer machines come with 6 to 8. All I really need is one for myself, unless I'm doing some advanced experimenting, but 99.9% of the time I just use one thermocouple. And so what happens is, once this starts reflowing, I'll have a graph, and it'll tell me my thermocouples are. So TC1 is our top heater, which will be in red. TC2 is our bottom heater, which will be in blue. And TC3 is our thermocouple temperature in green. And while I'm reflowing this, I'll want to know what the thermocouple temperature is so that I know that I'm achieving my reflow point, set point of the bottom side board temp for lead-free solder of between 190 and 220. And then you can go in there and you get a light, and you can get a light, or sometimes you can get cameras set up on these, and you can watch when the ball reflows so that you know exactly when it's reflowing, and you can document this. But if you're not watching the reflow, you can be pretty much assured that you're going to get a good reflow at 190 to 220 bottom side board temp on lead-free solder. And if you ask me how I know this, it's because I've been doing it for 20 years. and I have pretty much 100% yield on my rework, so you can take my word for it. But I said, take my word for it and then do it on your own, and you'll see how easy it works. So what happens is, I'll explain this to you right while we're waiting for it to heat up. Because the bottom heaters on these are pretty massive. They're hot air thermal type heaters, and so they take a little while to heat up. They take a little while to cool down. When we're restarting our profiles, we want to have those heaters back down to about 100 C temperature. We don't want to sit here and create a profile for a board and we start that has a heater started from, let's say, a room temperature, and then heating the board up for that long, and then if the top heater does not cool down, when we start at 200 C, it shortens the profile. So if our bottom heaters are pretty much not the same temperature every time we start the machine, then you don't have the duplicate profile every time. So I always try and have my machine start at between 60 C and 100 C on the bottom heater temperature. So what we can do is you can get on the SRTs, because they're pretty heavy heaters, you can get an external fan and blow it on the bottom heater to cool down. Or I'll show you how to go manually later into the commands and turn on the air just so the air flows through and cools it down. The machines can also be programmed. I'm not going to get into that, but you can program sequences. You can program these machines to pretty much do whatever you want. Have the nozzle come down whenever you want, to have the heat come on whenever you want, or the air to come on whenever you want. So right now I'm just going to show you how to do a manual override. I'm not going to get into program too much in-depth programming now, especially on the 1000, because the newer machines are a little bit different. A thing to note, our nozzle came down. So on your newer machines, up in the upper left-hand corner here, there will be a little knob, and it will allow you to manually lower and raise the nozzle. If you have a stop on it, and you don't want, for different thicknesses of boards, you don't want the nozzle to come down and slam into your board. So there's a stop. And so right now I have the stop probably about a 1/4 inch above the board. And for this machine, it's the older one, we just let it reflow like that. It seems to be pretty good. But if you want to get the nozzle closer to the board, on the newer machines, you can have a little adjustment. This machine has the adjustment, but it has to be adjusted with a little crescent wrench or socket wrench down there, because it's not made to be done by hand. So right now, we're wrapping our heat up 1 degree per second. And I can look at my screen here. My bottom heater right now is at 240, so it's just holding a straight line. My top heater is at 120, that's the red line, it's going up. And then my green line is gradually going up. It's not going up as fast as the top heater, because the board's taking a little while, the parts taking a little while to heat up. So we're waiting for our top heater to come up to 240 C. And once it comes up to 240 C, it's going to hold that for 60 seconds. And we can hold it for anywhere from 30 to 60 seconds. I usually hold it for 30 seconds, but for demonstration purposes, I'm going to hold it for 30 or 60, just to show you what I'm observing on the screen here. So what's going to happen is this graph goes up. I want to know that when it comes to 240, I want to allow it time that my heaters of top and bottom have both come up to 240 C, and they're saturated, and that my board has come up to 240 C and is saturated. Now, so what I do is I want this green line, once it starts timing out, I want it to flatten out a little bit, ideally. If it keeps climbing, and say I set my dwell to hold it at 60 seconds, and if it keeps climbing past that 60 seconds, that means that my board is still absorbing heat. So I can, if I want to, I can add more time on that to allow the board to absorb the full amount of heat. This is a slow ramp, so you can see the line just gradually increasing. So right now, we're almost at 240, so let's get it to 240, and then we'll observe what our temperatures are on the circuit board and the heaters. So top and bottom are at 240. It's counting down now, a 60-second countdown. The green line, the board is still climbing a little bit. It looks like it's starting to level off just now. So we got about 20 seconds more to go. Or 36 seconds, I'm sorry. And it's starting to level off now. That's what we want to see. The board has absorbed as much heat as it can. So if we start to level off sooner than 60 seconds, I can cut it down to 30 or 40. Once the board's absorbed all the heat it can, there's no reason to hold it anymore and keep heating. We want to go to the next level. So right now, with our top and bottom heaters at 240, our actual bottom side board temp is 150. So see, there's a big difference there. All right, so we timed out. Now it's telling us that again, we're wrapping our top heater to 270. You'll find out, because the top heater is smaller and the bottom heaters are thicker, our top heater will climb faster than the bottom heater. So again, that's where we're going to hold a little bit of time there at the end to allow the bottom heater to come up to the same temperature as the top heater. So we're having, I think, that 270 top and bottom at this point. And again, this is for lead solder. If this is lead-free solder, I would probably increase the top and the bottom temperatures on the preheat and the reflow. I would increase everything evenly by about 20 C, or 20 to 30 C, depending on how big the board is. So everything's at 270. It's counting down. Let's see. So our bottom side portion is only at 265, and I'm looking in there with a light, and I can see it's not reflowing completely. So this is again, this is a demo board, and so I'm looking at, we only got the 265. We need about 20 C more. So what I would do, if I would stop the profile and adjust my heaters up 20 C, and then rerun the profile. Now again, normally I would have stopped this way ahead of time if I knew it was going to come to reflow temp. So the idea about this machine is, if anything's not going right, you can stop it and start over. So normally, if I got in close to my countdown and I saw that my chip was not reflowing and I would need 20 C more, I would stop it, cool it down, restart the machine at 20 C higher. So right now I'm going to close this, close the graph. We're going to stop this. Takes us back to our screen. I want to close our screen here. What I'm going to do is I'm going to double click on the gray area to bring up my command menu. And I'm going to go over here to the word setup. And I'm going to click I/O diagnostics. What this will do, this will bring a screen up. Well, I can turn most of the stuff on and off and test it out. So I can test my airflow, how things are operating. But what I want to do, excuse me, is right here, I have my inputs, TC1, 2, 3. Remember, TC1 and 2 were our top and bottom heaters. And I want those to be about 100 C before I start my profile again. Right now, they're at about 170. So I can go here, and I can just turn on my top air. I turned on my top air. And when I turn it on, it's actually going to run air through the top and the bottom. And this is just cold air. It's not heated air because my heaters are turned off. And we're going to run some air through here to make sure that the heaters cool down to about 100 C. And basically, I just want my heaters to be a little bit cooled down before we start another board or another profile. So I'm not going to look what's going on more. Yeah, I'm about to 100, so almost down to 130 now. So while we're letting that run, let's see here. I'm not going to run them all the way down for our demo because it'll take about 5 minutes to get them down. So we'll just stop that for right now. And let's go back. Remember, when we come to our main screen, we have our board, our component, and our sequence. If we take our arrow and we double click on the gray area here, then our command prompts come up. We can add a board, we can add a component. More importantly, we can set up our profile and process steps. And then we have some other things here that normally you'll know what the engineers will get into. So I'm not going to go into that too much because those are more for setting up our sequences. We can go and program the machine to do specific sequences. For right now, if I want to add a new board, I can click on board, my speed up and down, and they give me some options, and I'll say maybe I want to add a new board. So I click on new, and I can enter the board name. So maybe this is a 215650 assembly number. I can pick my own reference, what thickness the board is. Is it an 062? Is it a 4 to 6 layer, 8 to 10 layer? I have some options there, and those are for reference only. The machine doesn't operate off that information right there unless it's an auto profile. What the machine does operate on, it operates off the board thickness. So it measures the board thickness and the component thickness in order to adjust when the pickup tube position is so that it focuses on the camera. So I want to make sure that if I put my board thickness in, which is 062. So once I have my board name and my board thickness are the primary things in here, I can save it. I'm not saving it right now, so I'll just cancel it. But then it'll save that board into my list of boards. And then I go to my component site, I can add a component to this board. So I can go from my standard list of parts, or if I want to add a new custom part to the board, say if I'm working on board 215200, and I could add the component by the component name. If it's Ozonics, I call it XCV2000 maybe, or maybe I just want to provide locations. So this is that board. I could add locations for U1, U2, U3, U4, as many locations I want for that board. So when I go to or an operator comes to rework the board, they will have that profile already set up for them. So right now, let's just say we're going to put our board name in, our component name in, either part number or location number. Then we can put our XY dimensions in, and again, those are only for reference. We can check if it's a square part or not, and then we can put in what nozzle size we use. So the whole idea of this stuff is when somebody comes up to the machine, they can select our board assembly number, they can select the component, and then the machine will tell them what nozzle size to use. So if somebody is not familiar with programming the machine, they'll know what to do. It'll tell them everything. Again, the important thing here, we want to measure the thickness or height of our components. So we want to measure it from the bottom of the ball to the top of the component. And then we want to put that height in here, because that will adjust our focus on the vision system. And if you remember earlier, I showed you where the balls, maybe they need to be stretched or weren't in focus. If those are not all exact, then maybe a little out of focus and may have to go manually focus. So that's why we want to try and get our measurements exact for the board thickness setup and the component thickness setup. And then we have, last but not least, we have on the bottom here, it says add the standard list of parts. So if I've got that component part number and it's all measured in the system, I can add it to my standard list of parts. And that way, next time if I bring a different assembly number in with that same component, it's already in my list of parts. I don't have to reset it up. So we've gone on how to add a new board, how to add a new component, and then again, for our profiles, we click on Process, Times and Temps, and then our profiles come up. I'm using a 1 degree per second ramp for the top or for the preheat and the reflow settings. And then I'm using a 240, 270. If I want to do lead free, I'd probably take it up to 260, 290. And that way, I still have it even. When you get thicker boards, you're probably going to want to use more bottom heat. So what happens is, my theory is here is if I have a thick board, it takes that board more time to absorb the heat. And so I want that board, I want those pads on the board to be at reflow temperature. If I sit there and I have this little bitty hot top heater throwing a lot of heat at a 36-layer board, it's really not heating that board up. It's just heating the chip up. It's throwing a lot of extra heat at that chip. Could burn the chip, could warp the chip. It actually could burn the top of the board area. So we want to have if we're doing big boards, 12, 15, I've done boards up to 36-layer. You want to have a robust bottom heater that'll heat up all those layers so that your top heater doesn't have to stress out and do a lot of extra work. One more thing here, you'll see we have additional post-reflow time, post-placement time. Those are if you want to do tricks. I normally don't use those. They do have a solidification time, and the solidification time is if I'm doing a removal on a chip, and it removes that chip, then before it places it up here on the upper net or the lower net, I could program it to hold it for 10 seconds, and it lets the solder cool down a little bit before it places it, so it doesn't put molten solder onto the metal here. So that covers it. Again, if I want to remove a part, I'm just going to go to the remove sequence. Click OK. And then what I can do, I can press run. I just move our thermocouple over first. So I'm going to move our thermocouple over to this leaded part. So I've just put the thermocouple on the bottom side of the board, directly under the part. I'm going to go ahead, I'm going to use my remove sequence, press run. And we'll start from there. I'm going to back up. I want to show you something again. We'll get too far into it. So let's close our profile screen. So I can run, if I know my profile and I'm not setting up the profile, or say I'm the engineer programming these machines, and I don't want the operator to get into the profile, I can put a password on this. So when you double click on here, you'll have to put insert a password for the command screen to come out. So you can program the machine so only authorized people can go in and set the commands. So if I'm an operator, I can also run the profile from the main screen. So I can run the sequences from the main screen, or I can do my process times and temps, and I can run the sequences again here from the profile setup screen. Just for demonstration purposes, let's say I'm going to do it from the main screen. Again, we have our sequence set up for remove. This is the SRT demo board. This is our generic BGA 225 component with the remove sequence. Let's go. It's telling me it's centering the site from the nozzle. I press go, so I need to center that site. I can adjust the lighting here so that I can see what I'm doing right now. That's my components there. That's my nozzle. I just want to get that component set up inside the nozzle so there's pretty much equal distance around. I usually use, if the keep out area allows, if there's not a lot of components around, I will normally use a larger nozzle so that you heat up a little more on the board and make sure we get some even heat on the outer edges of that part. For installing the chips, We don't. Some people use solder paste. All we use is a tacky paste flux. We use a no clean flux for lead solder. We use a medium active tacky paste flux for lead free solder. The medium active will give you better results if you're not using the nitrogen on your machine. And so we just brush a little bit of this on the board, a light coat over the pads, and that's sufficient to get you a good reflow. I like using the flux because it allows some cleaning and heat transfer action, and the tacky flux doesn't absorb it fast. It'll stay there through the whole process. So right now, let's set the site and nozzle and press go, which is what I did. I'm going to press go. And again, we're just going through our whole sequence here. Telling us what it's doing for the bond to heat up. It's going to go down and heat up. And once it's the temperature, it's going to remove the part. And so that's pretty much all I want to cover today. Unless anybody has any questions, you're always welcome to join the group chat. If not, you can call me or ask me questions later. Thank you for joining us. If you want or you can, please join my Google Plus page. And as we do these seminars, you'll be notified of our seminar times. We're going to be going over, right now we just covered our series on the SRT. We're going to be doing some series on shuttle stars. We have different model shuttle stars. We're going to be doing some on zoom out. And I'm also going to try and get some airbag demos in. So hope to hear from you. Hope to hear your questions. And please join my Google Plus page. If you need employee training, if you need calibration repair of an SRT, or if you need used equipment, or you want to get some nice new machines, give me a call. We cover it all. My name is Dennis O'Donnell. You can reach me at toll-free 888-406-2830. That's 888-406-2830. Again, thank you for watching and have a great day.